Hello everybody. Over here I am going to introduce experiential learning practice with the help of VLab. For that we need to get into vlab.co.in. In there I am getting into electronics and communication. Over there we have enough labs over there in which we're going to try with analog electronics lab. In that the experiment that we are going to try today is log and anti-log amplifier. So I'm going to get into that log and anti-log amplifier. Click on that. And over there, it is shown on the left hand side. We can see the aim, that is we aim, what are things that we are going to discuss. Starting with aim, we are going to study the log and anti-log amplifiers. And coming to the theory part of it, we know that these are electronic circuits which can basically perform the operations, that is the mathematical operations like logarithm and anti-logarithm, with a certain amplification factor, with an amplification. And these are called the logarithmic and anti-logarithmic amplifiers. And over here, we can see the applications comes as signal compression, process control, etc. Now coming on to detail of logarithmic amplifier, we can see that this is a circuit that we can use to perform a logarithmic amplifier. And over here, this is an op-amp, and to the op-amp, the negative inverting terminal of the op-amp, we are connecting a resistor to which the voltage input voltage is applied, and we can see a diode being connected in the feedback path. And when we derive the equations, with the help of the nodal and the analysis that we have network equations, once we reach at the equation, V naught is equal to minus n Vt ln Vi by R1Is. In this, Vi is our input voltage, V naught is our output voltage, and almost all the factors over here are constant. That is, we have Is, that is the saturation current of the diode. Then we have the Vf, voltage drop across the diode. Then it is forward bias. We can see Vt is the diode's thermal equivalent voltage, and this equation, we are going to have this equation as output voltage. We are going to see that the output voltage is proportional to the logarithm of the input voltage, proportional to a value, constant to a value, which is depending on the logarithm of the input voltage, where we have a fixed value for the resistance R1. The same way we can see an anti-log amplifier over here, whereby to the inverting terminal the diode is connected, to which the input voltage is given, and we have a resistor in the feedback path, and we can see a V naught output voltage over here. The non-inverting terminal is grounded over here, and for this also, with the help of network equations, we can derive an equation that reaches at V naught is equal to minus RFIs e raised to Vi by n into Vt. Over here, we can see V naught is equal to or proportional to anti-logarithm value of the input voltage Vi, and in this case, all of them, all other values are constant, having a constant value. And here we are considering, we need to keep in mind, we are considering a fixed value for the feedback resistance Rf. So this is the theory behind logarithmic and anti-logarithmic amplifier. Now coming on to the procedure, how to run the simulation, we can see that the component needs to be connected as specified in the instructions. Then we need to check whether the connections are correct. If the correct connections are wrong, it will be mentioned there. We need to rebias and make the connections correct. We need to connect it correctly. If the connections are correct, then we can move on to the start button to perform the experiment. We can see an LED button and a toggle button there to switch on and off the system. That is to give the power to the system. And then we have an option to give the input voltage with the help of a voltage range slider that helps us to fetch the values. Once we fetch up the different values, we can see that it is listed down in the bottom table, and then we can go for the plot. We will be able to see the output plot. So I'm going on to the simulation. We can see the simulation, it shows we have options for log amplifier as well as for anti-log amplifier. For the log amplifier, once I get into the log amplifier, we can see that it shows the connections over here. If we are in need of the instructions, we can click on the instructions, which will give the how to make the connections. So once we're clear with the instructions, we can start with the connections. Over here, the one is to be connected to uh, 3 over here, and this 2 is going to be, I'm going to connect it to the 4, pin number 4. I need to connect this 6 to 8 and this 5 to the output voltage point over here, so that this is where we give the input. So whatever values we give, it can be seen over here, and accordingly we'll be getting a voltage reading here. So for that we have a voltmeter over here. Now once I give the connections, I can check the connection. So I need to check the connections. Yes, it shows it's right connection, so else it will be prompted here. And now once it is okay, we can start with the simulation. So over here, the connections are complete, and we can see a power button over here. We need to switch it on, and if we can, with the help of this voltage slider, we can pick up the values from the voltage slider. So for different values, we can take almost 10 values over here, and for different values, we can see for each values, the input voltage shows the values that is set, and the output voltage meter, it shows the values that are obtained. Over here, we are performing with the log amplifier. So I got almost 10 values. So we cannot take more than 10 values over here. I'm taking these 10 values, and once I get these, I'm going to plot. I'm clicking plot. So once I give the plot for the values that we fetch over here, it is being plotted. So it is clear over here for the input values that we give, output is a log almost equivalent to proportional to the log values of the input voltage. Output is proportional to the logarithmic values of the input voltage. And if we want to take out this print, say PDF, or take a printout, we have the option for this print. And once if we want to restart again, try it again, we have an option for reset. In the same way, we can do the simulation for anti-log amplifier, where the connections can be given from 1 to 3, 2 to 4, 8 to 6, 7 to 5. And the same procedure can be continued, and we'll be able to plot the results for the anti-log amplifier as well. This is how we check the connections, and once the connections are correct, we can start with the experiment. And this experiment, we can switch on the power button, plot the different values, pick up the values from with the help of the voltage slider. And once we pick up different values, we can give a plot function over here, and that gives us the result, which clearly shows that the output is proportional to the anti-log values of the input voltage. Thank you for now.